Thank you for coming, everyone. My name is Andrés. I come from Colombia. I'm advised by Anil and Ronita in Cambridge. I'm going to talk to you about how to map urban forests. As a non-technical expert and more from the environmental background, I'll show you how I use all these programming tools to map trees in England. So why trees? This picture was taken like 2 days ago when I arrived. And I think like pretty much everyone agrees that trees are super important because they provide a lot of ecosystem services. They're places for social cohesion, not only like from the nature perspective. They provide air pollution reduction, temperature regulation, and are the staple nature-based solution for cities, which here in Singapore is a prime example. Singapore originally was covered in forest, and 95% of it was removed to build a city. So like 30 years ago, the government here said we're going to create a city in a garden, which they have successfully built, even though like, well, it's very urbanized. There's a lot of trees. Sadly, I'm not going to talk about Singapore. I'm going to talk about England. But first, I'm going to introduce a conceptual framework that was created by the urban forestry community, which is called the Tree 30-300. It essentially says that you should be able to see 3 trees from wherever you are in a city. Every neighborhood you have 30% canopy cover, and you should at least be 300 meters away from the closest public park. So taking this conceptual framework, many cities around the world in the last 4 years have started to like quantify or sort of measure if they're actually approaching this goal. But I took it a step further and I did all of this at the national level because every city has its own different approaches. So what I'm proposing is a framework like a standard framework that can be transferred to different cities around the world. For that, well, for those of you who have played around with geospatial data, and as Sadik and Michael have said, like there's a lot of different nuances with spatial data, the coordinate reference systems. We have vector data, raster data, graph data, which is a key component in this project. And then there's the scale. So in this particular project, I'm working with like all the buildings in England, which accounts for 29 million buildings, of which 24 are residential buildings, 3 million roads, and 16,000 public parks. And then I segmented almost 200 million trees, or 190 million trees in all of England. And how do I measure this at a granular level, at the building level in all of England? So this is what I'm going to show you. This is the programming part aspect of the talk. So as a non-expert in like computer science or programming languages, I'm mostly familiar with R and Python. And this is the full stack of tools that I've been using, mostly like LiDAR from R for tree segmentation, and then like a bunch of different libraries in Python for handling spatial data, parallelization and partitioning of spatial data. Like Sedona, GeoPandas, X-Array for raster-based datasets. And this is what it looks like. This is the tool. This is the tool that I created for the tree segmentation part, where we can see all the trees in England. This is for Cambridge, and we can the output of the whole process is a point for each tree, where you can see the top of the crown and the height and the area of the crown. So you can see like the different kinds of trees. Unfortunately, not species, just like dimensionality of the trees. And how did I do this? Essentially, what's happening is I'm taking LiDAR-based rasters that are processing in R using Del Ponte and Coombs algorithm and a local maximum filter to get like the top of the crown and then model the rest of the trees according to that. And that's where I get the 190 million trees, which kind of looks like this for a part in London. So what you're seeing here is all the buildings in this particular area, which ones are actually close to having at least 3 visible trees. All the green spots are trees. and the red buildings, well, 0 all the way to 9, within 25 meters. Then we have the canopy cover. This is a more standard geospatial like modeling, where you do zonal statistics using the same data set. I created, and using neighborhood data, you can model the canopy cover per neighborhood in England. And then the 300, the distance to the park, which is probably my favorite aspect of how I built all of this, because it uses the graph of roads. So the whole road network is used to create Dijkstra, or to calculate Dijkstra distance between the nodes that are closer to each building and to each park, to get where is the closest park to each building in Britain. And this is what it looks like. So I didn't mention, this is in London, in Tottenham. And this is what it looks like. How long it takes in actual distance to walk in the built infrastructure to get to a park from your house or from your workplace. And so this is the power of all these geospatial tools. But in addition to this, I took it a step further to use satellite-based imagery to like get more traditional spectral indices, namely water, vegetation, buildup, that looks something like this for the same area. So we can take like vector-based data sets, like the 300, with more traditionally traditional data from the remote sensing domain. And this is the end product. So we can map all of these variables for all parts of England and see where nature is more needed in urban areas. And finally, well, this is the first national assessment of the 330-200 rule, plus additional variables to complement other aspects of nature. This is a reproducible framework where we take like vector-based, raster-based datasets that are available in other countries as well. And it also uses open source data and libraries, unlike many different companies that use that produce similar datasets but with proprietary data. And this is an evidence-based like quantification of greening policies. Then the future step is obviously to transfer this to other areas or regions of interest in the world. And yeah, if you want to play around with either of the demos that I just showed, the first one is the tree segmentation, where you can see all the trees. The second one is the map with the zonal statistics of the different metrics, or you can see the code and contact me. Or you can see the poster later today and ask me more questions.
Thank you. How many trees did everyone think were in London? Go ahead. If you have any questions, go right up to the mic.
Sure. I have two quick questions. The Dijkstra diagram,
Yep.
I didn't quite understand. It looked like some of the houses that were very close to the park were very far in the color.
This one?
Yeah.
So yeah, like this one is actually modeling the distance between the access point to the park and the closest to the building.
Okay.
So it's not like like to any point of the like the park geometry is the access point.
Okay.
So it's a true like measure of walking to where you get to the park.
Right.
Yeah.
Okay, that makes sense.
Yeah.
The second question was: is there any relation between these metrics and deprivation in a certain area?
Yeah, there in the paper that it's
Okay.
in a preprint. I kind of shared the QR code for now. There are relationships between deprivation and nature accessibility in England. There's this thing called index of multiple deprivation that measures different levels of like socioeconomical conditions, like health, crime, income, and there's definitely a correlation between number of trees and level of deprivation. So like poorer areas tend to have less trees, but contrary to what you would believe, poorer areas have, or on average, live closer to parks. So that's something interesting that we found, which is like, is not what you think. Like you would think like richer areas have like park like at 10 meters, but it's not the case. It might be because they have gardens. So like many houses have their own like proprietary green spaces, which were not accounted for in this particular analysis.
Okay.
Yeah.
Thank you.
Do we have any other questions? No? In a weird coincidence, I used to live there in 1997, and you can actually jump across a fence to get into the park. So
Oh, really?
you don't have to go all the way through, but the police do keep an eye out for you. So.
Yeah.
Let's thank Andrés again.
Thank you.